Good morning all. Myself Anita Arshitar. Along with me Parvati Ramachandra presenting a video on experiment on Lcr circuit prescribed in the course Engineering Physics Laboratory by VTU. The aim of the experiment is to calculate resonance frequency, bandwidth, quality factor and inductance used in the circuit using series as well as parallel resonance circuit. Frequency bandwidth can be calculated using F2 minus F1. Quality factor can be calculated using the formula Q is equal to Fr divided by bandwidth. And self-inductance of the coil of inductor can be calculated as L is equal to 1 upon 4 pi square Fr square into C, where Fr is the resonance frequency, C is a capacitance of a capacitor used in the circuit. See, Lcr series connections are shown in the
we have here video. 3 inductors and 3 capacitors and 3 resistors. I am using L2, R2 and C2. So this is L2. So L is connected to C. So here I have 3 capacitors. Let me connect it to C2. L is connected to C2. From C2 it goes to R2. So it is a series combination. So L is connected to C, C is connected to R. Then next end of the R is connected to the one of the terminal of the ammeter. The other terminal of the ammeter is connected to signal generator. The other end of the signal generator goes to this another end of the inductor. So this is the circuit of Lcr series. So L is connected to the C, C is connected to R. So Lcr, this is fed to this circuit. We are feeding a signal from the AC source, and to measure the current we have in series with this ammeter, milliammeter. Next what we have to do is
now let us see how to conduct experiment using Lcr series circuit.
After connection we have to record a frequency response on this setup and also on the AC signal. So first set this one to the maximum amplitude, and this one you keep on the sinusoidal, and this one frequency you keep it as 1k, and this multiplier you keep it on 1. So for 1 kilohertz the current we observe is 1 milliampere. Ampere. Next let us increase it to 2. Now frequency is 2 kilohertz. For 2 kilohertz the current reading is 2 ampere. Now let us bring it to 3 kilohertz. So for 3 kilohertz it is 3 milliampere. 3.2 milliampere. Next let us keep for 4. For 4 it is 4.1. Next let us keep it for 5. For 5 kilohertz the current is 4.8 milliampere. For 6 it is 4.7. For 7 it is 4.2. For 8 kilohertz it is 3.7. For 9 kilohertz it is 3.2. For 10 kilohertz it is 2.8. Now let us bring this to 1 and switch this one to 10k. So 10k we get same 2.8. Now let us go to 11. So 11 means 1.1 here. So 1.1 into 10 is nothing but 11. So for this the reading is 2.7. For 1.2 it is 1.2 multiplied by 10 means 12. So it is 2.6. Next for 13 kilohertz it is 2.4. For 14 kilohertz it is 2.3. For 15 kilohertz it is 1.9. So this is how we must record frequency response. As we increase the frequency, what happens to the current? We have to note down. This is for series. Similarly, we have to do it for parallel.
Plot the graph of current versus frequency. So as you increase the frequency, this is how the current is varying. So you can see a maximum current at the peak that you have to note down. It is 4.8. So 4.8 is the maximum current, I maximum. You can see here I maximum is nothing but 4.8 and I maximum by root 2 if you do it is 3.4. So at 3.4 you draw a parallel line to the frequency axis where it cuts the curve here, that is nothing but f1, and where it cuts the second position, that is nothing but f2. So from the graph we can note down f1 and f2. f1 comes out to be 3.2 kilohertz and f2 comes out to be 8 kilohertz, and the maximum current where we have is the corresponding frequency is called as resonance frequency, and it is found out to be 5 kilohertz. So this point, so this is nothing but 5 kilohertz. So we have noted from the graph FR, F1 and F2. So we can calculate the quality factor. Quality factor is nothing but FR divided by bandwidth. FR is 5 divided by bandwidth is it is nothing but 8 minus 3.2. 8 minus 3.2 comes out to be 4.8. So bandwidth is 4.8 kilohertz. So if I take the ratio, this comes out to be 1.04. So the quality factor for the series is 1.04. It will tell us about the sharpness of the signal. And we have to calculate the inductance using this formula. L is equal to 1 divided by 4 pi square Fr square into C. So 1 divided by 4 into 3.142 square of this. Fr we have seen 5 kilohertz. So 5 square is 25. Kilo square is 10 to the power of 6. and the capacitance value is 0.1 microfarad, which we have used. 0.1 micro in the sense -6. You can see -6 plus 6 get cancelled. 4 into 25 is 100. 100 is multiplied by 3.14 square. So the answer comes out to be 98.7, including this 0.1 also. 98.7. So this comes out to be 0.0101 Henry. In terms of millihenry, you can shift this decimal after 3 digits, that is 1, 2, 3. So it becomes 10 into 10 to the power of -3. That is nothing but 10 millihenry. Here we can list the result obtained. The resonance frequency we have seen for the series, it is 5 kilohertz, and bandwidth f2 minus f1 comes out to be 4.8 kilohertz. And the quality factor we have seen, it is 1.04. And inductance we have seen 10 millihenry. Lcr parallel circuit connections.
One end of C and another end of the C also I have taken 2 wires. So this C is connected in parallel with L. So I have to connect this to the I am using L2 here, so let me connect here. So this C is connected in parallel with the capacitor. Next, from the one end of the connection, it should go to the resistor. The other end of the resistor must go to the other end of the resistor has to go to the one end of the milliammeter. The other end of the milliampere ammeter must go to the signal generator. This is short wire. Let me use long wire here. One end goes to the signal generator. The other end of the signal generator must go to the other end of the combination. This completes the circuit. So what did we do? We took 2 wires here. One wire I am sending it to the inductor. From the other end also I am sending one wire to the inductor. And other 2 wires which I have here, one should go to the resistor, other must come to the signal generator. Other end of the signal generator has to come to the one end of the ammeter. The other end of the ammeter must go to the other end of the resistor. After this, again, this is the connection.
Let us see how to conduct experiment for parallel Lcr circuit.
I have to set it for 1K and this is for 1. So as the frequency increases, we have to note down the current. Now this is for 1 kilohertz. For 1 kilohertz, the current is 4.9 milliampere. Next, let us go for 2 hertz. For 2 hertz, the current is 4.4. For 3 kilohertz, the current is 3.4. For 4 kilohertz, the current is 1.9 milliampere. For 5U, it is 0.0.0.0.0.0.0.0.0.0.0.0. For 0.6, it is 1.2. For 6 kilohertz, it is 1.2. For 7 kilohertz, it is 2.4. For 8 kilohertz, it is 2.9. For 9 kilohertz, it is 3.5. For 10 kilohertz, it is 3.8. Next, I have to bring this one to the 10K. 10 into 1.1 is 3. It is 4. Next, 1.2, it is 4.1. 1.3 into 10, that is 13. For 13, it is 4.3 milliamps. For 14, it is 4.4. For 15, it is 4.5 milliampere.
Now let us see the frequency response plot for the LCR parallel circuit. You can see here, as the frequency increases, this is how the frequency response curve we obtain after plotting the data which we obtained from the experiment. So from the graph we must note down where the current is minimum. The corresponding frequency is called as resonance frequency. Here also, in this case, we find this is at 5 kilohertz, and we have to multiply by root 2 to this 0.3. So we obtain it as 0.424. So this is nothing but 0.424. Okay, this is at 0.3. So 0.3 multiplied by root 2 is 0.424. So draw a parallel line to the frequency axis where it cuts at the first time, that is f1, and where it cuts here second time, that is f2. So by noting f1 as 4.7 kilohertz and f2 is 5.2. So we can calculate bandwidth and quality factor. Bandwidth is nothing but f2 minus f1, and quality factor is fr divided by bandwidth. Fr is 5 divided by f2 minus f1. f2 minus f1 is 5.2 minus 4.7. It is 0.5. So 0.5. 5 divided by 0.5 is 10. So this is quality factor for the parallel circuit. Now let us calculate inductance. As the frequency is same as in the series resonance frequency is same. So the similar calculation we are going to get, because, and the result will also be same because we have used same inductor here also. 3.142 3.142 square, and FR is FR in this case is also 5 kilohertz. So 5 into 10 to the power of plus 6. And the capacitor value is 0.1 microfarad. So 0.1 into 10 to the power of minus 6. Minus 6 plus 6 get cancelled. So 5 into 4 is 20. 20 into 0.1 is 2. 2 multiplied by square of 3 point. So it comes out to be 1 divided by 98. This is 5 square. So 5 square is 25. 25 multiplied by 4 is 100. 100 into 0.1 is 10. 10 into square of this. Square of this is 9.87. Multiply with 10, so it becomes 98.7. We are going to get 0.0101 point is here. It is inductance, so measured in Henry. So I can write it in terms of Henry by shifting the point 1, 2, 3. So it is 10 into 10 to the power of minus 3. 10 to the power of minus 3, I can write it as millihenry. So the inductance used in the circuit is 10 millihenry. Let us list the result obtained from the LCR parallel circuit. The resonance frequency obtained is 5 kilohertz. Bandwidth is 0.5 kilohertz. Quality factor is 10, and inductance value obtained is 10 millihenry. After performing the experiment, you should be able to answer these questions. What is resonance? What is the condition for resonance? Why the current is maximum in series and minimum in parallel resonance? Define self-inductance of the coil. Why series circuit is called a high-pass filter and parallel circuit a low-pass filter. Compare quality factor for series and parallel and analyze it. Thank you.